first section of the chapter 1. So 4 ways to represent a function. So we'll kind of go through these. So function, exactly one element. So 1x goes to 1y. So as long as 1x goes to 1y. And then we have a function. So we can't have 1x go to two different y's, right? So that's a definition of a function. So we have domain, those are our x values, right? And our range is our y values. X values, input, these would be our outputs. What we get out, y values. X values are domain, inputs, what we put in. So what, in usually most cases, we usually get to pick the x, to plug in order to solve for y, because usually all our equations are solved for y, our output. So usually we get to pick the x, and we solve for the y. And then independent variable, that's usually your x's, because you get to choose those. All right, they're independent, you get to pick them. Where dependent, based on what you pick, these would be your y values. Most times would be your y values, right? Y is dependent on what I choose for x. So dependent variable, independent variable. I guess this word's not, that's choice, choose. So usually those are your x values. You guys are used to now being not able to spell. So here's a quick example. Find the values of f1. So I look at this function, f of 1. So f of 1, this is my x value, because normally it's f of x. So this is my x value. So I go to my x value, and then I see what my y value is. So f of 1, meaning when my x is 1, what is my y value? Well, my y value is 1, 2, 3, is 3. F of 5, meaning what is the x value, or what is the y value when my x is 5? So 1, 2, 3, 4, 5. 5 right here. So negative 7.5, so negative 3/4, something like that. I'm just kind of guessing. What are the domain and the range of f? Well, this whole function is f. So domain has to deal with your x's, right? And we always read domain from left to right. So domains go from left to right. So we start here at our first x is 0. And we go, and 0 is included, right? We do have a y value for that x value, so we put that in brackets, and then we go all the way up to 5, 6, 7, all the way up to 7, and we do have an x value or y value for that x value of 7, so we put that in brackets. The range goes from bottom to top, so the lowest y value to the highest y value, so negative 2, and we do have a y value of negative 2 up until 2, 3, 4, 4, and we do have a y value 4, so we put those in brackets. Okay, so here we're asked to graph, so y equals mx plus b here, right? Y equals mx plus b, and that's an x. So that's an m. What am I talking about? Choose mx. There we go. So we go ahead and go down -1, put a point, and we go up 2, 1, 2, over 1. There's second point, so there's our graph, and this is a linear line, so our domain, it keeps on going to the left, so it's all real numbers, and it keeps on going up, so it goes down, continues to go down, continues to go up, so our range is also all real numbers. Our domain, it goes from left all the way to right, and it keeps on going both ways, where this one is a quadratic, right? So it looks something like that. We have 0, 0, we have 1, 1, we have -1, 1, 2, 4, -2, 4, so it's quadratic. So left to right, it's still going to the left and it's still going to the right, so domain is still all real numbers. All quadratics are. And then our range is the lowest, which is 0, and it does hit 0, but then it goes up and up and up to infinity. All right, third one, if we have a function, here's our difference quotient. So we're doing the difference quotient of this, so f plus a of h, so that means all these x's are going to get a plus h, and then they're all going to get a's after I subtract that. So I plug in a plus h, so a plus h squared times 2 minus 5 a plus h plus 1, and then I'm going to subtract, plugging in a in for my x's. So that I'm subtracting a 2a squared, I'm subtracting a negative 5a, so that's a positive 5a. So notice I'm just changing the signs here, and then a negative 1 because I'm subtracting a positive 1. And the whole thing's over h. And so then we're going to work this through, square first, so we get a squared plus 2ah plus h squared, all times 2. So this is a 2, this becomes a 4, this becomes a 2. Then minus 5, distribute that 5a minus 5h plus 1 minus 2a squared. Remember on these ones from last year that everything that doesn't have an h is going to get canceled. So that means 2a squared, 5a, negative 1, positive 1, so I get 4ah plus 2h squared minus 5h all over h. You can factor out an h. So we factor out an h. 4a plus 2h minus 5 all over h. H's cancel. Now we have the difference quotient here. So that's our difference quotient. Okay, find a domain. So we have square root function. So we can start plugging in numbers. We can start at negative 2 because negative 2 makes that 0. Square root of 0 is 0. And then I can plug in 2, and I get 4. Square root of 4 is 2. So it's going to look something like this. And then square is plus or minus, so really it does go down like this. So really this one wouldn't be a function because for this x value right here, I actually have 2 plus or minus 2. But sometimes we only look at the principal square root, so we only look at that half. So the domain is going from this x value all the way up. So our domain is from 0, including 0, all the way up to infinity. Sorry. And then our range goes from negative infinity to positive infinity because it continues to go down, it continues to go up. If we're just looking at the principal one, it would be 0 to infinity. All right, this one a little bit different. You can start plugging in x values. Can't plug in 1 because we get 0 on the bottom. So it's everything but 1. So basically we can't have 0 on the bottom, right? So 1 and 0 we can't have, but everything else will work just fine. So if we take this and just set it equals 0, because we can never divide by 0, factor out an x, I can set these both equals 0, x equals 0, and x equals 1. We can't have those, right? So it can be everything but that. So negative infinity up until 0, can't have 0. Then from 0 to 1, everything in between there I can have, and then everything after 1 I can have. So it looks, in interval notation, it looks like that. So that would be the domain. Okay, go ahead and answer this question. I'm sure you know it. What's a way to just look at a graph? So if I have a graph like this, how do I know it's a function or not? If I look at a graph like this, how can I tell? Well, that's the vertical line test, right? This one fails. So fails, this one passes, so that'd be a function. Okay, then we have a thing called piecewise function. Don't know if we talked about this a little bit in pre-cal or not, but here it is. It's basically more than one kind of equation, or pieces. That's why I call it piecewise function. So this represents one part of the function, and this represents another depending on what our domain is. So basically this is saying all numbers from -1 down. So -1, -2, all those numbers, we use this equation to graph. And all numbers bigger than -1, we use this equation to graph. So we want to find f of -2. So which one are we going to use, the top one or the bottom one, if our x is -2? If x is -2, then we're going to use this top one. So we're going to plug in -2 in here. Go ahead and solve, we get 3. So f of -2 equals 3. -1, we also use this one, right? Because it's or equal to. So we're going to use that one again. So f of -1 equals 1 minus -1, which equals 2. This last one, f of 0 is bigger than -1, so we're going to use this equation. So 0 squared is 0, so f of 0 equals 0. So based on where your x is tells you which equation you should use in a piecewise. Okay, graphing absolute value. So we can plug in 1, we get 1, plug in -1, we get 1 as well. So it almost looks like a quadratic, except for it's really a straight line here and a straight line this way. So negative slope on this side, positive slope here, because really this is just a piecewise function, x and negative x. So if your x value is switch that is greater than or equal to 0, we use this function. And if it is less than 0, we use this equation. So if I plug in -1, it would be less than 0, so I plug it into this equation. So it's negative x, here's my x, -1, and it's a negative x, so that becomes positive, so that's why it's right here. So it's basically two lines, right? This is an equation for a line, and this is an equation for a line, and that's what makes up this absolute value equation, or function. So a step function kind of looks something like this. Literally looks like you're taking steps. One's closed circle, one's an open circle. So if your function is usually in a piecewise, x. So y is equal to 1 if your x's are greater than or equal to 1, but less than 2. And your y value is, say, 0 if your x's are from 0, including 0, up until 1. So that'd be something like that. Okay, symmetric, if it's even, that means when I plug in a negative x, I would get the same answer as just plugging in x. That's an even function. An odd function is when I plug in a negative x into my equation, I would get negative f of x. So the classic examples for these is f of x equals x squared, quadratic, because it's balanced on both sides, right? Same point here, same point here. This one's a cubic, right? Because if I have this x, say, is 2, and I get 8, when I do -2, I get -8, right? Negative f of x means just opposite of your opposite, so opposite of your y value. So I get the opposite answer when I plug in a negative x. Okay, neither, well, if it's not even or odd, then it's neither odd or even. So not necessarily, all quadratics are even, because if I have f of x equals, say, x squared plus 4x, when I plug in, say, 2, right, I get 4, I get 8, so I get 12, right? So if I plug in 2, I get 12. If I plug in -2, here I get 4, right? But when I do this, I get -8, and so I get -4. So f of -2 is -4. If it was even, I would also get 12. So not all quadratics are even, but it's also not odd. I didn't get an opposite of that answer. I didn't get a -12. All right, increase and decreasing. Last slide. We talked about this last year. As we look from left to right at on our cross-star domain, as we look across our domain, what is our y values doing? Is our y values going up from left to right? So that would be increasing. What are valid? If they are going down, then it would be decreasing, right? So looking at our domain as we go from left to right, is our graph going up or down, and from where to where? So increasing and decreasing will tell us, it'll make up our domain. Okay, so increasing technical definition, as we start on this x, and as my second x is bigger than that, then by definition of increasing, my y value of the first one is smaller than the y value of the second one. And then decreasing, if my x is smaller than my second x, then my first y will be bigger than my second y. So that's the technical definitions of increasing and decreasing. But as you go to left to right, is your graph going up or is it going down? Under 15 minutes, that's not bad. There.